They made it to the periodic table, which is going to be your best friend for the next month or so. You're at home, but that doesn't mean that our learning can stop. We are going to learn a lot about our new best friend. Specifically today, we're looking at this worksheet right here. We're going to fill it out together. This first little bit up here, this should be a little bit of a review, and then we're going to move on to some new stuff down here. So let's define what an element is. Let me zoom in a little bit. An element is matter composed of only one type of atom. Now if we go back to our table, each of these boxes with the letters in it, they represent one type of element. And there are about 103 known elements in our universe, but scientists believe that there are more that they are going to discover. Let's get that definition down. So right in the top here, what are elements? That's the box we're going to be filling out. Let's go with blue. Why not? Elements are matter composed of one type of atom. Matter composed of one type of atom. Now, the element symbol is basically how we tell that we are talking about this specific type of element. Each of them is made up of letters, you'll see, and most of them have two letters, but some of them, especially at the very top here, have only one letter. And that is a rule, that they will always have either one or two letters. So let's write that one down. Make this a little bit smaller. They will always either have one or two letters. Elements and their symbols will be made up of either one or two letters. And there is a rule that the first letter is always capitalized, and if there is a second letter, that will be a lowercase. And that's what we're going to put right over here, is that the first letter is always uppercase, and the second letter always lowercase. Now before we go on, let's take a peek and see if that rule applies and if we can check if it's true. Let's go. This is the top of our periodic table. This is our smallest element over here, hydrogen. Hydrogen only has one letter, and it is capitalized. So let's try and find another one. Let's go over here to helium. Now, it has one or two letters. Check. First letter is capitalized or uppercase. Check. Second letter is lowercase. Check. That means that it makes and follows all of our rules for naming our element symbols. Let's just make sure that we got that down. Let's put an example. Now you don't have to be switching between your colors as much as I am. So let's put an example. Let's say that H, that was the first one we looked at, that means the symbol hydrogen. H, capital H, lowercase e, that gives us helium. Whenever you're going to be asked to write out element names, I want you to make sure that you're following the rules of this box right up here. So I'm going to zoom in. If you need a little bit more time, you can pause the video right here and make sure that you have that copied down. Alright, now that you do, we're going to move on to talking about the specific reasons why certain elements are in certain places. And we need to understand the words periods and groups first before we do that. Now we have to look back at our table here, and you'll notice very, very small that there are numbers on each of the symbols here. It starts over here, hydrogen, with 1, all the way to helium 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So they are in a specific order, and that has to do with the size of the atom, and that is how that they are arranged. So let's make sure that we got that right here. Let's say that the periodic table is arranged by what we call is atomic number. Now let's make sure that we understand what atomic number is. Definition for that is equal to the number of protons. Don't worry about that too much just yet. We're going to go over that in a little while. Okay, let's move this over. All right. The actual shape of our periodic table. You'll notice that I was reading across, left to right, just like we would read any piece of writing in English. We would read left to right. The periodic table can be read left to right. Now, if we follow and look at different lines, left to right, left to right, well, these are actually called a specific thing when we do that. And they are called a period. So I'm going to highlight, just change my arrow. Let me change this to a big red arrow. And we're going to say that this, when they are read across like this, and this isn't specific to this one, this could be up here, this could be down here. Anytime when you read a cross, that is called a period. Let's get that over here. Horizontal rows, and they tell us how many electrons, or electron levels, are occupied. Now again, for now, don't worry too much about what this means. We will get there. But we need to know that what these are called are periods. Periods. Let's make sure that's big so we can make sure that's the button turn here. Horizontal rows that tell us how many electrons are occupied. Now, we got one more. We got arrows going down. You can probably guess this next one. We're going to be talking about when instead of going across, we are going vertically. Now, a vertical line, now imagine, right, this could be over here. This could be over here. It could be over there. It is anytime we're going down like that. Now these are called rows. A group. They're called a group. We'll say that they're like columns or vertical columns, and they tell us how many electrons are in the outermost energy levels. Again, Don't worry too much about this. What we want to get is that they are the vertical columns. That is the really important part here. So let me just highlight what I really want you to be able to tell me. Now, where is my highlight feature here? Nope. Bear with me. I think we got it. There we go. Periods are horizontal rows and groups are vertical columns. That is a really important part. So far what we've learned is we've learned that elements are labeled with either one or two letters and that the first one is always capitalized. We've learned that when we read across in rows on the periodic table, those are called periods. And if we read downwards, those are called groups. Now we can take a look at what one of those tiny symbols looks like. Now, the one that we're looking at, fluorine, is found right over here on our table. And to understand it, we have to understand the different things that are in the box. It's not just the letters. We have the number 9, the full name of it, and we have another number at the bottom. Now, this number 9 is something we've already learned. It is the atomic number. So we can put that right beside it there. Atomic number. Is the, which is, remember, the protons and electrons. So it is the number of protons. Then we have the atomic mass at the bottom. So this is this number at the bottom here. Atomic mass. Fancy word for saying the average of all isotopes, or the number of protons and neutrons in the atom. Now, why wouldn't they all be the same? I told you that matter is composed of only one type of atom. Well, even when they're all the same, they might be missing one neutron, or they might have an extra neutron, and I'll add a video which shows what that word isotope means and how they're actually pretty cool and used in a lot of science, like in nuclear power plants and in a lot of things like vaccine development and stuff like that. So let's calculate neutrons. We know atomic number on this side right here is the number of protons. And we know that there are 3 different types of mini little particles inside of an element. We know that there are protons, neutrons, and electrons. Now, if we want to calculate how many neutrons are, we already know how many protons there are. And there is a fancy formula that will let us figure out that additional information. And it is as follows. It's the atomic mass subtracted by the number of protons. So we have the atomic mass, which is this number at the bottom, minus the number of protons, which is our atomic number at the top. So we can say that in 2 ways. We can say it like that, or we can say atomic mass minus the atomic number. And that can give you how many neutrons are in each of our elements. All right, quick review one more time. The important parts at this bottom part here, periodic table. The rows going across, the horizontal rows, are called periods. The vertical columns moving up and down, those are called groups. We found out where to find the atomic number as well as the atomic mass on each of our different elements. You'll notice that they are all present on there. And then we just found out how to calculate how many neutrons are in an element. The only thing we have left to talk about is this one down here. So let me just extend this so I can pick that up. An isotope is an atom of the same element with a different number of neutrons. Element with atom of the same element with a different number of neutrons. All right. Good job getting through our notes today, everyone. These notes will help you when you move on to your next worksheet, which talks about groups and families on the periodic table. All right, stay safe. Bye, everyone.